AX, Y. So Alice starts at A, and then X and Y are the two places you want to be able to get to first. If Alice is between X and Y, then Bob has to either be on the Xth side of Alice or the Yth side, the left or the right, and neither of those could work, because then if it was the other, there's always going to be one possibility that won't work. So if Alice is between X and Y, then it doesn't work, and if Alice is before X and Y or after, then it does work. So I think it's just making sure that Alice isn't between them. So res is going to be A is greater than X, and A is less than Y. Can they be A, X, and Y are pairwise distinct? Okay. This is a div 2. A, interesting. A is greater than X and A is less than Y. If X is greater than Y, swap X and Y. Looks pretty good. No, no, yes. I guess I have it backwards. What was that? Did it submit? No, I guess it didn't submit. Weird. I have the world's most bitter grapefruit juice. Div 3e, two integers a and b, we define f of a and b as the number of positions in the decimal representation of the numbers a and b where their digits are the same. So 12 and 21 would be 0, this would be 1, this would be 19891, 18981 would be 2, 54321, okay. So two integers L and R of the same length and decimal representation. Consider all integers between that. Your task is to find the minimum value for any number x between them. The minimum value. So that would mean the minimum value. Seems like digit DP. Seems like you could go digit by digit and say, it's a little bit more complicated because with normal digit DP, it's usually like the number of things between two numbers is how it's often phrased. And then what you can do is you can say, okay, we'll just take all of the numbers that satisfy some condition or the sum of all numbers or something below R and subtract the sum of all numbers below L. But here you can't really do that because you're maximizing something, so you can't take the maximum of all numbers below R and then take out everything below L. I'm going to need an upper bound and also a lower bound for my digit DP. So it's going to look a little bit wonky. T, L, and R. All right, pretty basic. The minimum value of f of L and X, f of X and R. I also immediately want these to actually be strings. Like I'm going to turn them into a string anyway. Okay, well the maximum value, for example here, is going to be something like 9. Or 18, I guess, because you're adding both of them. 10 to the 9th. So it could be 10 to the 9th, which means really 20 is the maximum. Is this even digit DP? I'm not even really... It's the maximum of everything in a range, but that's different than the... Yeah, I think it could be digit DP. It's just like if you chose this future digit with a given constraint. So what is that constraint? What are the actual... What's the actual like state space I need for my digit DP? So any x is less than or equal to any x where L is less than or equal to x is less than or equal to R. Okay, yeah, it is less than or equal to. Such that x shares min digits with L or R. So it's going to be something like dp of, we're going to have the index in L and R because they're the same length of string. I think there's going to be have you broken the upper bound and have you broken the lower bound? And I think that's kind of it, because what you're returning back up is the best you can do beyond this point. You just thought about me. I love hearing that from people. Someone messaged me and was like, can you post your VODs? Because I guess a couple of my friends like to look through these. Where are they? Video producer. But they all get so DMCA'd. I'm pretty shameless about it. I'm going to listen to what I want to listen to. So I'm going to stream them to YouTube as well, just for posterity's sake. What made you think about me? Okay, and then this is returning the min. Yeah, don't fuck with YouTube. I figure I'm such a small account, like who would care? Although actually when I've uploaded videos, they've cared. They've like gone back through and... Did I stream last Friday? I don't remember. August 9th. So that would have been, yeah, last Friday. Last Saturday, maybe? I've been working. I haven't really been working, but I've been grinding these Codeforces problems. I've been getting like better and better at them. Yesterday I took a walk in the morning and I got back in, oops. Let me open up Chrome here. I have this extension that shows like the rating of the problems that you do. Yeah, I did a 2600 rated one yesterday. That felt good. So I'm back on that grind. This is 2900 rated. This is the highest rated problem I've ever seen. But I looked at it and I'm like, it doesn't seem that difficult. It seems like it was just made like 10 years ago. So that's in the back of my mind. Min score from this state on. All right, it seems pretty basic. Or I don't want to say it's basic because it's not the most basic thing, but I think I have a good understanding of what to do. So res is 20. Res does not need to be 20 now. Res is going to be something like, and I can use a DFS because the recursion is never going to go more than like 10 units deep. So res equals DFS of 0, 1, 1. This is saying you're at index 0. As far as you're concerned, the left and the right elements are both... The left and right bounds both are still there. DFS is equal to that. Let's get... what's this returning an integer? Okay, perfect. Do I want to call these LB and UB? I think I'm going to call them EC1. I usually call this EC for like, are you still at the upper bound or are you below it? So I think I'm going to call these equals 1 and equals 2, which is, I'll know what it means. And that's because I'm going to establish an upper bound and a lower bound right here. And I want to use that terminology like in the code. Okay, first things first, if I equals n, and I'm just going to say int n equals L dot size. And I guess I can just submit n in here. I don't know. I don't want to pass any arguments by reference because if I do that, maybe it's fine. What do I do that? Or do I just say n? I just say n. Okay. If I equals n returns 0, that means you're looking at an empty string and it will definitionally share no characters with L or R. Okay. L has to be, okay, less than or equal to R. Perfect. Lim is equal to, do I need a 0? I think I need a 0 element to be like, is this leading zeros? Am I looking at leading zeros? How do I normally handle that with digit DP? I'd say try assigning a 0 everywhere. Normally I don't have to care about leading zeros because you just say for every number up to R, you can say, okay, let's say R is like 10,032. You'd say, okay, well, I can only assign a 0 or a 1 here. If I said start with 20,000, immediately that's too big. So like any number below this, if I'm trying to calculate some aggregate of all that stuff, this needs to be 1, and then this has to be 0, because it can't be above that. But now I could have this be 0, 1, 2, or 3. And as long as this is anything other than 3, then the final thing can be anything 0 to 9. Or I could say this is a 0, in which case anything could be anything from 0 to 9, and it would still be legit. But I can't do that here because I don't want to calculate things that start with 0. So I think I'm just going to say like limit, I'm going to say lower bound is equal to equals 1 question mark. This is saying, okay, if you're still equal to the lower number, if so far you've been equal to L, let's say your max is like 999 and your min is like 333, and you want everything in this range. If the first thing you said was a 3, you can't have a 2 here because that's too small. So if you're still in a state of equality, you have to be at least a 3. So if it's equals 1, then int L at I. Or else, and then I need another question mark, which is a little confusing, but I equals 0, 0, or else 1. No, the opposite. I can start at a 0 for anywhere except the very first index. All right, fuck it, whatever. This is gonna take everything. I don't think it's gonna be, what's the actual time complexity of this? I think it should be very basic. I think it should be like O of log n. That's it. That's like really basic. Which means I don't really need DFS anymore. I think that's a pretty low level optimization anyway. Int RB is equals 2 is a thing. If so, int R at I plus 1, and I'll just add that after. Or else 9 plus 1. So this is exclusively the number you can go up to. For x, from LB to RB, and then I'm going to say, okay, try assigning this value. So score is equal to, and I'm going to say int res equals 20, return res. I need to cache all this, but I'll deal with that in a minute. If I is n, return 0. If cache at I at ec1 at ec2 doesn't equal -1, return cache at I at ec1 at ec2. Int cache 10 to 2. Should be good. I think just to be safe, I guess I'll have this be 20, but it shouldn't matter. Okay, looks good. So the cache is all set up. Score is going to be x equals int L at I plus x equals int R at I. So if it's the same as either of these, add that score in. Score plus equals something, res equals min res score, and then return res. So it's going to be DFS of I plus 1, ec1, and x equals int L at I. And then ec2 and x equals int R at I. Looks pretty good. So what's the problem here? I have that. DFS takes 3 things. I'm putting 3 things in. A variable declared with an auto type specifier cannot appear in its own initializer. So I think I do need to say like which is fine. Okay, that looks pretty good. Looks very good. Uh-oh, this was 12. It was supposed to be, or this was 11. 2103 22133. 21032 21032 11134 21133. So that means this fourth thing, 21032 210321. Okay, I know what I'm saying. This fifth test case, the sixth test case is having problems. So this should say 1. 1, 2, 3, 4, 5, 6. 199 to 201. So what are you supposed to put here? Probably 200. Because then you have the 2 and the 0. There's not really any way around either mirroring the 1 and 9 or the 2 and 0. But if you do 1 and 9, you have to do 199. You can't do 198. If you do 200, you can do 200 as opposed to 201. You have 3 integers available to you. Okay, so I kind of want to check if I equals 1 and ec1 equals 0 and ec2 equals 0. What's the problem here? Oh. Print res. So this should happen exactly once, or 0 times? No, it makes sense that it would happen 0 times. No matter what you choose at the first index, you will always still be identical to the right bound or the left bound. So I meant actually to have this be a 1. This is, you just chose a 2. Res is 0, which is not correct. It's saying no matter what you do, it's saying you can choose any option past this, and there's an option that doesn't cost anything, which is not the case. So let's see what happens if I put the score in. Interesting. So X is going up to 49. Way too big. So probably there's some error right here. Okay, LB is 0. That's correct. RB should not be that. I'm guessing it's like an integer conversion thing. Int L at I, int R at I. Okay, it's that I'm converting to integers and it's not doing the right thing. So what I want to do is say, well, what happens if I just say int x equals r at 1? Is it smart enough to automatically convert it to a 0, or will it not do that? No, it'll convert it to a 48. So I think I need to say r at 1 minus 0. Yeah. So my integer conversion is not right. I think that's the only one. The only place. Zero. Fuck. Should check in on that every once in a while. What's the actual left bound and right bound that are being brought up? 1 and 3. That doesn't seem right. At index 0, the left bound is 1, the right bound is 3. No, that is right. That is right. It's saying you could choose a 1, you could choose 2, that's it, because it's exclusive. Okay. When you're at index 1, the left bound is 0, the right bound is 10. Yeah. But the right bound shouldn't be 10. The right bound should be 1 in this world. And it should also have parsed another index, which is when the left is equal but the right isn't. This is saying you're equal to both. Okay, this is saying you're equal to neither. Oh, it's probably the same problem here. I forgot about these. One, 1, 0. This is saying you are equal to the left bound. You chose a 1. Now all you can choose is a 9. Okay, and then all you can choose is a 9 again. So that looks right. I must want to say, like... Oops. They're all 0. Oh my god, it's the same thing here. What am I doing? Okay, is there any reference of int? No, those were actually the last ones. Okay, there's the 2. That's a good sign. Uh, 210 322 1334. 210 322 1334 351218. That looks good. I doubt it TLEs. There's not really any way it could do that. Nice. Needle in a num sack. What a weird name. Oh my god. Okay, so it's interactive, I guess. Div2D. Well, I'm guessing that means this doesn't really mean anything and I can't test this. That's kind of tough. You found the k numbers and n. You found the numbers k and n in the attic, but lost 2 arrays a and b. You remember that the order of a and b is n, and both of their orders are greater than or equal to k. So I'm guessing k has to be less than or equal to n times divided by 2. Yeah. The arrays consist of only numbers from 1 to k. Okay, weird. You can take any consecutive elements from array A and they will all be different. Any k consecutive elements. Okay. Also, if you take any k consecutive elements from array B, they will all be different. That tells me immediately what the structure of A and B have to be, which is they're entirely like stair-step ascending 1 through k, or the opposite. Or not necessarily stair-step, but they have to be the exact same repeating pattern of k characters. And k is only 50, which is very good. So I can't bit mask that, I can't have that be a factorial, I can't try all those. But if I can figure out a way to like look at all the repeating patterns of k, if I can get it down to that problem, then my time complexity is like extremely lenient. Fortunately, a kind spirit that settled in the attic found these arrays and concatenated them into array C of length n. That is, the elements of array A were first written into C, then the elements of array B. You can ask the kind spirit up to 250 questions. Each question contains an index I. In response, you'll receive the ith element. Okay, I think I see what you need to do. So you're given C. C is this big array. There's some delineation somewhere where on one side you have A and on the other side you have B. And you need to be like, I guess you're what, recovering the original arrays? You need to find the lengths of arrays A and B. So I think what you want to do is find the periodicity of the first set of patterns in A, find the periodicity of the last set of patterns in B, and say, okay, this is the exact 50 element pattern in B and in A. With that would cost you at most 100 of your questions. And then you have 150. With those 150, you need to parse the rest of the n elements to find out exactly where that delineation is. Which is not obvious to me how you would do that, because this is where I'm trying to get back to. 10 to the 6th over 100 is 10 to the 4th, which is well above k. The sum of n across test cases is not limited. Interesting. After outputting a query, do not forget to output a new line and flush the output buffer. Okay, perfect. cout.flush. I'm just going to pop this in here. So once you have these initial patterns, you could binary search it. Worst case, the pattern of A and B is exactly the same. I'm guessing that can't be the case. And also this is divisible by k. Because then you would just say like, anything, like there could be any line between A and B. It doesn't matter. There's like no difference between them. Or report that it is impossible to determine them uniquely. So it totally could be that. So it's impossible to %k equals 0. You don't even need that. If pattern A equals pattern B, report -1. Okay, and then if it's not pattern at B, then you kind of know for a fact exactly where you can call exact indices and say exactly right here, that's going to correspond to something in A that's different than something in B. But it's a little bit confusing because if you aligned B to be like %k is the same as A, then you could just say like, okay, well, what spots in B are different than what spots in A? But you can't really do that if B is aligned with the end of the array. You might be able to just like dedicate a buffer with B and say, and now check this. Yeah, I think that's what you would want to do. Check n minus k times 2 to n minus k. So you literally sacrifice 50 of your elements just to do that, and either these were exactly the same, in which case you would have already reported -1, or at some point in this 50, they're going to change, at which case that's the exact moment where you're looking at A, because this didn't match up with that for every single index. Or it didn't change, in which case you know that this is the same as this, or I'm sorry, as this. You know that this is another spot where B is, and if you know that this is another spot where B is, then you could align it according to K, because this is a length of at least K. So then you have a spot where you say, okay, A is going to have these values, B is going to have these values, and then you could binary search in here. Which I'm not going to think too hard about, but it's worth... What's my time? 8 minutes? Yeah, I'm not going to get that. But it's worth just at least making sure that that's possible. So you'd say, at what exact point does A end and B begin? And 1,000,000 log 2 is 20. So if you dedicated 150 of these, you said, okay, this is 50, this is 50, this is 50. Let's say you spend another 50 on the binary search to get at least within 50. What would you do? You could find, you would choose a specific index in A and B, and you would say, okay, right here is different. So you'd binary search, you'd find that index here where it's different. Greater than or equal to K. And then in that, you would need to find the surrounding area, but you only have 50. Impossible to determine them uniquely. Okay, you could say this is the lowest point. This is the first moment at which they differ. And then you would find that first point. You would find the final spot where this A is at that first point, and then you know somewhere between that and the next cycle, there's B. There's the line between A and B. And then you could iterate through all the points that are different. I think you could just iterate through literally all of the points and say, spend your final 50 on that. So iterate through every single point, and then you would need to determine either there's either going to be an exact pivot where an index I minus 1 needed to be A, and I needed to be B, or if that never happens between this instance where it's A and this instance where it's B, then there's not a uniquely determined partition. So you would report that. Okay. I heavily doubt I'm going to be able to code up an interactive problem in 4 minutes, but I think you could definitely do that in, at the very least, exactly 250 questions. And it would always take less than that, because this is going to be more like actually less than or equal to 20. So you have 30 left over always. Okay. To make a query, do a question mark with an X. To report your answer, output a string exclamation point A, B. If it is impossible to determine the lengths, output exclamation point -1. Note that if you answer -1 while there is a sequence of at most 250 queries that uniquely determines the lengths of arrays, you will get a wrong answer verdict. Yeah, that seems fine. The interactor is not adaptive, which means the answer is known before the participant makes queries and does not depend on the queries to be made by this participant. Okay. What is the input? N and K. That's it. Okay. So I'm guessing this is kind of gibberish, like this doesn't really mean anything. Or maybe this is saying like this is the amount at which you could, like if you played optimally, you could get it in 3 guesses, so they're like giving you that input in case you wanted to simulate it. Codeforces, that's hell. I know. Codeforces is the worst for that. I'm always thankful when I do Atcoder and I'm like, oh my god, I can actually see the test case. Or CSCS is really nice for that. So output this string and then read an integer, but also make sure to flush the output. Okay. So first things first. Well, no, what's tough though, these aren't of length exactly k, these are of length greater than or equal to k. So this whole idea of periodicity, I don't think is actually right. The total length of the arrays is n. I think actually this idea that there's this periodic repeat of... Oh, no. What am I talking about? Yes, that is true. That's the whole point of this. No, I questioned everything there for a moment. So I'm kind of considering A and B to be repetitions of the exact same k consecutive elements. Okay, I'm not crazy. For I, from 0 to k, print question mark I. But I'm guessing it has to be I plus 1. Yeah. Okay, and then also n minus I. And then this is b at k minus 1 minus I. So with this, I should get some sort of large sequence for A and B, or not very large, some sort of sequence. Okay. I think what I want to do, because I'm going to have B and I'm going to have like the buffer for B. That's going to be like 101. So I think what I really want to do is say, just do these separately. I is n. I is greater than or equal to n minus k. I minus minus. I kind of want the corner case of just if it's less than 250, if the length of the entire thing is less than 250, then just like read the entire thing and go from there. I like this. Yeah, I think I'm going to do that. That way I can just directly have this be like... So what's after this Leetcode? Yeah, and I don't give a shit about this problem. I'm going to go ahead and say this hit 0, so I didn't get this problem. Because this sounds like an absolute nightmare to implement, and I don't really want to do that right now. I think interactive problems are cool, but I kind of planned out what to do. And I feel like the simplicity of that and the complexity of implementing it, there's a huge disparity there. And I don't want to spend the next like 2 hours implementing this. After you hit this 3,647th problem. I'm kind of curious actually what the difficulty of this is. I'm guessing like 2100 or 2200. $2,200, yeah. Looks like I got it right because it says binary search. So then that's pretty much what I was going with. I guess I could do some zero track problems. Optoelliptical, if you have a preference, like would you prefer for me to do Leetcode? Because if not, I might even do like CSES. Those are pretty fun. What was the difficulty of the previous one? I'm going to guess the difficulty of this was 1900. Whatever it was. Alright, I'll do some CSES. $2166. Did I actually do $2166? You solved more than 2,500 problems. Oh my god. I gotta get that rating up. Once upon a time, my problem solved was like so far below my rating. And then the LLMs hit. YouTube. Okay, introductory, sorting and searching. I could do some, I feel like DP problems are always fun. I was gonna, what was this one, 2166? Prefix sum queries. Okay, I have done this. I think I was looking up like I just don't want to have a problem like in here that I haven't done. It looks like I haven't done room allocation. Alright, well I don't want to do room allocation, so... Counting towers. Your task is to build a tower whose width is 2 and height is n. You have an unlimited supply of blocks whose width and heights are integers. Okay. Well, I feel like there's probably an exact formula for like if you have a height, if you have a width of 1, what's the height of that? N is 10 to the 6th. So input, how does this even work? Number of test cases, oh, and then just n, okay. $24, $13. So I feel like a central thing for this problem is like every time you're at a certain height, you can kind of do one of two things. You can either place a block that can be any length, and then you're basically saying the sum for dp at j is less than I. dp at I. Or you place a block of height 1, and then it's kind of the same thing, but times for each of these the number of ways there are to configure blocks of size 1. Or blocks of width 1. I don't think that's not a super obvious answer, because this you can kind of get an O of 1. You just keep dp as a prefix sum going up. This though, no, maybe. Because I guess if you think about it, like, if you're placing this big block and then you're looking at dp at I minus 1, you could also have placed 2 small blocks and looked at dp at I minus 1. So I think a better way to say it is not like place 1 big block or place small blocks. It's this times like the number of ways there are to place blocks, which is just dp again. So it's going to be like dp at I minus j, such that j is less than I. So you'd say like, okay, draw the partition here. So it's going to be like dp at 2 times dp at 4, and then dp at 3 times dp at 3. Is that even true? I don't even think that's true. Because what if you placed a block that was like this, and then another block that was like this? So in this world, there's not really any exact partition that's going to get this. And you can't store the height difference in the state space. That's not really good enough. Well, I don't know. I think my first idea was better. There's really only two things you can do. There's either place a whole block or place a partial block. And if you place a partial block, you're just saying what's DP at here times this thing. And then you have to deal with like, how does this scale and how could you calculate all that in O of 1, which is like not super easy, but still possible. And ways to fill one column, I don't think that's as difficult. I mean, obviously it's not. That's like, that's just like dp at I is going to be equal to every previous sum. So it's sort of like a weird Fibonacci numbers, but like every previous number instead of just the last two. So you would say 1, 2, because you could have this or this, and according to my pattern, it's going to be I guess every previous element plus 1. So you could say, okay, for 3, I'm expecting that it should be 1 plus 2 plus 1 is 4, which I think checks out. So it would be, you have that, you have that, you have that, and that. Has AI killed Leetcode? Yeah. I don't I think it's killed the contests by and large. It sucks, but it kind of has. I mean, like, who's to stop someone from having ChatGPT just telling ChatGPT, oh, get rid of your comments and make it look like a human wrote it? Like, I think as far as the contests are concerned, yeah. I think there's utility in maintaining the hobby. I think it's fun, but so then the question becomes, okay, I've figured out how to get f of I minus j in linear time. That's fine. How do I multiply that across each dp at j? So I say there's one way to get dp at I minus 1. There's 2 ways to get dp at I minus 2. There's 4 ways to get dp at I minus 3. I mean, does it just multiply by 2 each time? Maybe that's the pattern. I think it does. Because 1 plus 2 plus 4 is going to be 7 plus 1. So that means 4 is going to have 8. So actually that's it. You multiply your previous dp state by 2 each time. So you'd say, add in the sum of all previous dp, and then I guess you would have 2 numbers. Yeah, it does suck. Not trying to be toxic, but I feel like it could be 2600 now. It's called using ChatGPT. Yeah, I think that like there's still things that are out of ChatGPT's grasp, and Leetcode is trying to be part of that, but once upon a time, I feel like Leetcode was more about just transparently asking data structure and algorithm questions, like as a job interview bank. And then they started doing contests, and it was like, they're kind of different, and it's a lot more self-contained than other competitive programming sites. And now I think they're trying to be like, oh no, wait, like our problems also need to be that, or else there's no point. but it's like there's a whole world of contest writers, like contest problem writers, and I don't think Leetcode is up to par with other sites. That's why I don't really do too much Leetcode anymore. Because a lot of the way they try and confuse ChatGPT is being like, they'll call like greatest common divisor like highest scoring number between X and Y and stuff. And I think you can't really, it's harder to phase ChatGPT wholly with something like that as opposed to like something that actually is like novel. So you say dp at I is equal to the entire previous dp space, and also I think you just need two numbers. You need yeah, okay. I barely even need this like solve thing. I think I could just say like input n res dot pushback dp at n. Oh my god. For int x in res, print x. Okay, good. dp is going to have 10 to the 6th elements. I think what I actually really want is I want to say like LLY is equal to dp at I minus dp at I minus 1. If y is less than 0, y plus equals mod. Oh my god, I can't stand when songs do that. It is like a nice instrumental, but prefix sum of ways. I also kind of want like what's the current number of ways to it's like it's confusing. I'm gonna want another number though in order to fill up dp. So I'll say for I from range 0 to 1,000,000, or I guess 1 to 1,000,000. So dp as 0 is just 1. There's one way to have nothing. And then I'll say dp at I is equal to dp at I minus 1. And if dp is a prefix sum, you're saying get the entire prefix sum up to this point. You could always just build you could always just say it's the number of ways to build any previous layer. So do that. dp at I plus equals, and it's really that times 2. because it's also, it itself is part of the prefix sum, so you want to add dp at I minus 1. But then also there's like cur. I think I could say dp at I plus equals cur minus equals dp at I is greater than mod else 0. Cur plus equals dp at I. Cur goes up. I'm doing that to avoid divisions. I think that looks good. The height is n. There's really 6 ways. I think my logic is flawed. Damn. Because I'm still not accounting for this and this. I think there's multiple things I'm not accounting for. I guess you could say there's really only a few things you could do at each stage. You could say for each dp at I, from dp at I minus 1, I could raise this block and add a new block. Or raise this block and raise this block. Hey, urinator. I think this is a much more sensical way to do this. And then you would really have your state space would be multiplied. You'd say dp at I at 0 or dp at I at 1. And what that would represent would be like either you're at a flat top or this is split. And then you would have certain rules. You could be like, okay, if I'm at a flat top, I can really only do one of 3 things. I could raise this up so that I just extend the current block. I literally build a new block, or I build 2 new blocks. Okay, this makes much more sense than what I was doing before. Going through the same DP series with the same problem set. Maybe. I don't know. I saw him like debating wanting to do CSES, and then he said, he was like, I like to not do that on stream because I don't want to give everyone the answers. And then I said, I will do it on stream because you have to watch me struggle for like an hour before I actually give you the answer, or myself the answer. So that's going to be that. dp at 0 is 1. dp at 0 at 1 is 0. And this is saying when you start out, it's just a bare bottom. Yeah. Get rid of that. Sounds like Li-Fi. I think it is. What am I typing in this tiny window? When or if I reach 2500 on Leetcode, I'll start Codeforces grind. I guess that's what I did. I think that's probably overkill though. I think you could probably start on Codeforces. There's some people who are like very good at Codeforces and not good at Leetcode. I think that's a minority because you need a lot more like data structures and algorithms knowledge for Leetcode at like the same skill level. Why is dp at I minus dp at I minus 1? That's not relevant anymore. I'll say y minus equals y is greater than mod or else 0. Okay, that looks good. Now to actually build the DP array finally. So DP at I at 0. I think you're kind of saying when I'm at a flat top, there's a few ways I could have gotten here. I could have gotten here by this is a new block and the very last thing that happened was a flat top. This is a new block and the very last thing that happened was a separated top, or I'm extending a flat top. Those are really the two things that can happen. So I think it's going to be dp at I at 0 is equal to dp at I minus 1 at 0 going up by 1 or multiplied by 2 minus equals dp at I at 0 is greater than mod 0. dp at I at 0 plus equals dp at I minus 1 at 1. This is you place a new flat bar. What's up, Kakashi? Welcome to the CSCS grind. Okay, and then dp at I at 1 is going to be equal to... So this is now you're here. There's some situation where you made it here. You seem to have changed a lot. How so? I don't hear that very often. That's interesting. I grew a mustache and a mullet, actually. That's quite the change. So you could either have begun from a flat top, I think that's the only real way that you can go from having a flat top to having a separated top is just by placing two new blocks. So that handles that. And then dp at I at 1 could have been this is a block and this is extended from something else and whatever was here just ended. Or the opposite, that's a block, this extends. Or they both extend. So there's three ways. So dp at I at 1 is plus equals dp at I minus 1 at 1 times 3. I think I can be smart about this. I think I can say dp at I minus 1 at 1. And then this bit shifts, so that's a little bit less complicated. And then also that makes it nicer for the mod. I can still kind of do this. You look more buff. That's a good sign. I worked out, I think, the hardest I've ever worked out yesterday. That was an unbelievable workout. I was like, I feel like a good workout, I won't even do cardio, and I'll still have sweat dripping down my face. And I'll be like, wow, I'm going hard. Yesterday was like several cycles of sweat dripping down my face. It was like 5. How much do I bench? So that's probably why I look more jacked than I used to, because I've started going to the gym a lot more. At my height, I could bench. I think it was nothing crazy. I think it was like 2 plates on either side. So what's that? 90, 90, 45, so 225, something like that. But that has absolutely dived into the ground, because almost exactly this time last year I had like open heart surgery. And what's your body weight? I think I'm like 180 right now. And like they literally ripped all my ribs open and like peeled my pecs back and stuff. So I remember I asked my doctor constantly. I was like, when can I go back to the gym? When can I go back to the gym? And I knew the surgery was coming up. So like going into it, I worked out every single day for like an hour, because I was like, I know I'm going to atrophy like the guy from The Walking Dead. Like I'm going to be like waking up from a coma, and like my bones are going to be all spindly. And I did lose like 25 pounds of muscle. And I'm just now getting to a spot where I'm like, I'm not going to like kill myself. I'm not going to like rip my heart open or something weird if I like bench. But I go really easy on bench. I do just free weights. Okay, I'm sitting here talking about stuff, but I'm not actually running this. So with 2, the answer should be 8. Why is the answer going to be 8? It's going to say you can do either of these. Well, let's just see. No point in talking about it. 3. Shit. So what's it doing? It's probably, I kind of want to see like DP at 1 at 0. DP at 1 at 1. And let's get that for 2 at 0. And I guess 0, 0, 2. And 0, 1. Just to be exhaustive. Why open heart? I had pectus exudatum. I still do. The surgery didn't even go that well. But it was like interfering with my breathing. Like it was like painful to breathe in a little bit. And it was getting to a point where I was like, this could be covered by insurance, and also is kind of painful. 1 and 0, it's saying there's 2 ways to have something of... that's true. So let me go back here. How is the answer when n equals 2, 8? I think that's actually worth discussing, because I don't really actually see how that's possible. Can you sue the doctor? Maybe. I actually am going to go get a second opinion. In my yearly checkup, they called me and I was like, I mean, what the fuck, guys? And also, it's just fucking insulting. The doctor, like, will be like, okay, get here at 8. That's when your appointment is. And literally, I will bring lunch. I'll bring my laptop charger. I'll be there until 1 or 2 p.m. It's like, why would you even say come in at 8? Like, just tell me to come in then. But the doctor, he was like this weird sadist. Like, he seemed to get off on it. And his poor staff. But anyway, I'm digressing. So you could have that. You could have that. You could have that. So immediately I see how there's many more than 3 ways. You could have this in no particular order. You could have this. You could have this but backwards. you could have this, and you could have this. Right? That's 8. I think that's it. American doctors are so bad. I know, they're very weird. I know a couple good ones. This one just really gave me the creeps. And this is not the first doctor I've had where I'm like, how did this guy get his license? That's the American way. That's how we do it. So what is mine saying? Mine is saying, look at DP at I at 1. Or, yeah, look at DP at 1. DP at 1 is saying there's 2 ways to have... I think DP at 1 should be 1 and 1, right? There's 1 way to have this and 1 way to have this. Yeah. And the rest of these I could entirely extrapolate from 1, 1. So 1, 1 should give like 5, 3. Also, why is this returning 3 if it's 5, 5? If that's 5 and 5, DP at I at 0 plus DP at I at 1. That's actually kind of weird. Oh wait, it's saying I is 1. For I from 1 to t plus 1, input n. So I guess I never inputted t up here. No, I did input t. What's going on here? T is 1. Okay. Oh no, wait, I said I and not n. Oh, and that's probably exactly what it is. This needs to be DP at n, not DP at I. Of course. Dahoy. Okay, but I did uncover something useful, which is exactly DP at I at 1 should... At 1 at 0 should be 1 and not 2. And that's because there's nothing prior. So actually this should be... I'm just going to say at 1 at 0, at 1 at 1... And then this starts at 2. And then hopefully they don't say, what's the number of ways? Yeah, there's n can't be 0. Do I CPP? Uh-oh. So it should be 0, 0, 1, 1, 3, 4. So it shouldn't be 3, 4, though. No. 3 is correct. It's saying it sees this, it sees this, it sees this. So DP at 2 at 0 is fine. DP at 2 at 1 is only seeing 4 things. It's probably the fact that there's something being multiplied. So this is the state where DP at I at 1 plus equals DP at I minus 1 at 0. Which is included. And then I have 3 situations where you can go up from DP at I minus 1 at 1. Which is this, this, and this. I think I didn't include both of them. So I could also do this. So in fact there's 4. Which means I'm just going to do a percent. I don't care. It's going to be like this. Okay. Very chill. I feel like problems where I go this slowly, usually I'm like infuriated and I'm like scratching my head. 2864 640403945. Perfect. Never saw you doing CPP. I think I use C++ significantly more than Python at this point. Edit distance. I think this is straight up a Leetcode problem. Rectangle cutting. Given an A by B rectangle, your task is to cut it into squares. Each move, you can select a rectangle and cut it into 2 rectangles in such a way that all side lengths remain integers. What's the minimum possible number of moves? Okay. How's the Japanese truck? Oh, one of those little trucks I mentioned a while back. Yeah. There's one of these on my street. I know. I'm pretty shameless. I don't care. I thought a friend gifted you one. No, although that would be cool. I hope a friend gifts me one. I think it was that maybe I mentioned I'm helping one of my friends get like an old ass truck, kind of like that. Because they got like fucked over by a car salesman. A and B. Okay, so what are we actually doing here? This was a very satisfying problem to solve. So we have some rectangle, and then you're, I think, basically just going to make partitions over and over again and say, can I do that? I think the first thing to recognize is, given any rectangle, it will always contain a square, and you could always just remove that square, or it might even contain several squares. So I guess you could say, like, if you have some huge thing where like this is X and this is Y, you could always just say, okay, well, my new rectangle is going to be Y%X, comma X, where you're going to say there's a bunch of there's a bunch of squares of size X here. Let's say like that. And this is a square. So partition these. This is the rectangle sliver you're left with. Oh, I thought you were talking about my username. Yeah, Urinator is a great username, especially with the 78. It invites speculation about your age. Is there ever any reason why you wouldn't do that? The minimum possible number of moves. A and B are only 500. So you could just have your state space be 500 by 500 and say, right? You would just be like, okay, I have a blank by blank rectangle. No, because you would need it to be a 500 by 500 state space where you also try cutting at every partition. So you need a way to have your state space be 500 by 500 and then have an O of 1 transition. Because I don't think there's any way you can represent the state space in less than X and Y. I mean, maybe you could do something that's like the ratio between X and Y, where X and Y are both integers, but that seems convoluted. So then that makes me think, okay, well then you kind of want to do this. Do you have to? Can I prove that this is the only thing you could do? That this is optimal? I feel like the worst possible case scenario is if you had let's say 499 by 500 rectangle. And then what you would do is you would say, oh, okay, perfect. Well, there's a square right here. So let me just take that out. So I've created one square, but now I have 499 squares I need to make. So the answer would be 500. Can you do this in any better than 500? I think you legitimately can't, but it's worth trying to prove that. Does 499 have any factors? Oh, okay. Well, 499 is prime. So I think maybe in a way this is a bad example. Yeah. You can do it in 15. I wonder how you got that exact number so quickly. Oh. It's like, oh my god. You just did that in your head? You broke this up into 15 partitions of blocks? That's insane. Well, yeah, I mean, like, at the very least, you could say... I feel like you could say something that's like... Just have a square not of 499 by 499, but you could even have it just be like 496 by 496. And then these could just be 3 by 3s. And these could be 4 by 4s. And then you get some corner case, but it would be negligible at that point. So, like, you could always just do that. Kind of a Chad. You bench a lot, right? You bench like several plates. Someone was asking about that earlier. $4.99. So then I guess I need to go back to the drawing board. Less than 4. So I've proven you can't, or BetSimp has proven you can't just draw squares. You can't greedily take squares. I feel like maybe I've encountered problems on CSCS where I go, oh, of course, it's O of n squared, and then the answer is it's O of n cubed. But I think that's rare. I feel like that happens more on Codeforces than anywhere else. And I feel like what happens a lot on CSES is that even when I get the right time complexity, my like low level implementation is like not very good. And with 1 second, I don't think I can do 500 million operations. Or like more than that. I think it would be like 500 cubed. What's that? 2.5 billion? Yeah. If it was O of n squared, it would be 1000. Yeah, I guess in my mind I was like 500, like geometrically speaking, is closer to 1000 than 100. And because of kind of what I just mentioned with CSCS versus Codeforces, I'm like, I want to err on the side of like being conservative with my time. But I feel like that in and of itself is kind of a hint. Like, it's probably worth thinking about. what it would look like to do something that's like more than O of n squared, like O of n squared root n or O of n squared log n or something like that. Because around 1e8 operations per second is a safe estimate. Okay. That's good to know. So it would be maybe it's like some weird harmonics series kind of thing where it's like you're going to have a bunch of squares, and what that's really going to amount to is like if you have a length, like a side length here, and you have a bunch of squares, you're going to say, okay, well, I could draw squares of size 1. I could draw squares of size 2 that are going to go like all the way over. I could draw squares of size 3 that are going to go all the way over. ... and that's going to be n log n to look at each of these partitions. But that's kind of assuming maybe yeah. Okay, you know that you're eventually drawing the whole thing into squares. So you know that there will be some square right here. Whatever size it's going to be, there has to be a square here. So if there's a square here, you could say just reduce from one side. Let me think about this. I don't know how helpful that is actually. O n cubed is 1.25e8. Yeah. Well, I was off by a factor of 10, but yeah, I guess that's like kind of off the table. So I'm thinking of something. Cut must go through the entire shape. Oh, then there's like an exact Leetcode problem that's just this, right? Cut two rectangles in such a way that all side lengths remain integers. Well, select a rectangle and cut it into two rectangles. Cut must go through the entire shape. It specifies the cut must go through the entire shape. Yeah, into two rectangles implies your cut has to go through. I see what you're saying. Yeah, okay, yeah. Yeah. Okay. Well, in that case, you know... Let me think about this. You know that this is going to be some sort of square on this corner. So you could say go up from here, and then you're going to get like 3 other rectangles that you're going to have sorted through. That's not great though, because it's an O of n transition, and you have a side length of n by n, or like a rectangle of shape n by n. Rectangle you're making the cut on. Yeah. Okay. I feel like there was a really similar Leetcode problem to this that was like you start from one side, you deciding what line to cut. So I think I want to start from first principles a little bit and say, what do you absolutely need? You need X, you need Y. I heavily doubt there's a way to say this can be represented in one dimension. That seems not right. So you need those. And then for each X and Y, there's basically there's X plus Y choices you have. There's all these and all these. So naively, if you were just like choose one of them and you're good to go, that would be O of n cubed. Not good enough. I guess you could get it down to logarithmic with some sort of binary search, but you'd have to show that like the closer you are to some optimal point, the better choice it is. But I don't think that's true, because like 360 versus like 361, I feel like this is like a super composite number, and this is like probably not even close to that. So I doubt there's monotonicity there. Is there any way to like use a sparse table and be smart about that? Yeah, I think. I think maybe what you could do is you could say, you already will have, okay, yeah. You already will have parsed, for any dp at ij, you already will have parsed all of the smaller rectangles. So if you found a way to do this, like you've already solved this problem and this problem. It's just a matter of like you don't want to look through all of them. So if you've already solved them, what you could do is you could say, look through every single problem where you made a horizontal cut. You would need a lot of sparse tables, but I think you could do, I think there's like room. Hopefully there's no like fractional cascading stuff, but. And then you could say, okay, instead of choosing between all of these, I'm just going to call a sparse table query on it, and that's O of 1. But really it was O of log n to build it. And then I'm going to go through every X and say, okay, and now what if I like went up 1? Then what? And then add all of those into a sparse table. It's a little bit weird because I would need like cross-hatched sparse tables for each X and Y, but I think that's fine. That's kind of weird though. No, maybe it's not weird. Maybe you don't need a sparse table. Maybe you just need a prefix minimum. Because you're never really calling any query. This is always in ascending order and starting at 0, if I'm not mistaken. So you could say, all right, forget the sparse table thing. You could just say like, if you had a prefix minimum, that's pretty weird. I don't know about that. Because the prefix minimum isn't saying like, do this. Maybe you would need a sparse table, actually. Let me go back to that. Because if you said, what about if I made a cut here? This is what you wanted to do. You'd be saying, like, well, then I have this and I have this to query. Oh, no. I don't think that's a good solution. because it's true that you could query these like in O of n or O of 1, but like you have to match this with this. And then if you're even at y plus 1, you're matching this with something else. Is it any use to say there's the 499 and 500 case that disproves that you would want to just naively draw squares whenever you can, but if you had x% y equals 0, does that prove that you would always want to exactly draw these squares and that's the minimum amount? I think it does, because any other line you draw, you will need to have subdivided here and here, whereas if you just drew this as a square, you wouldn't have to. So you always want to greedily do this when you can. But is that even that helpful? Is that really that helpful of an observation? Because that doesn't mean you just want to draw lines that are like squares always. I don't think there's anything to the sparse table thing. I don't know if that's a good idea. Oh my god. Is there... Maybe this is cheating, but I feel like there's a Leetcode problem that's basically this. And then the question is, have I done it? Okay, I've done this. Return the minimum number of integer-sided squares that tile the rectangle. Although this is different because n and m are 13. So I think this is in a way a completely different question. It's nice to know that this is considered a hard when the constraints are like not anything. If you always went in from a corner, if you always went in from a corner, I think I might just be thinking in circles here. You'll get some X and then 3 new things. I think there might actually be something there. No. Maybe the sparse table thing is what I want. Yeah. I think maybe I was a little too quick to give up on that idea. So you have all of this. No, but maybe a segment tree. Maybe you could use a segment tree. Because the problem with a sparse table is you would have to create one here when you were at this X and Y. And then create another one here when you're at this X and Y. So it doesn't actually really help you. But if you used a segment tree, you could say, in this entire range of all of these cuts I could make, what's the best one? So what would that look like? Would this really be... How many people have done this? 27,000? So it's one of the most done problems on dynamic programming. Let's look at range queries. Alright, yeah. Like a lazy segment tree is like kind of in that range. Well, maybe not. I think if it's a segment tree, it's actually going to be quite complicated. Because you're going to say, it's not just find the best cut. It's you have both of these rectangles that are each elements in your segment tree. This is like a 7 and this is a 3, let's say. And then you would say, okay, well, the minimum cut is like f of 3 plus f of 7. And then you would need these segment trees like for all of this. Maybe a 2D segment tree is a little simpler. Maybe. I think a 2D segment tree, you would say, okay, this is the entirety of my segment tree right here. And then for any given ij combination, what's the recurrence relation? It would be the min of all I minus 1 j and I j minus 1 plus 1. Right. Well, maybe it's useful to go through their example. So if we have 3 and 5, then I guess you would say, okay, well, 5 by 5. And then you have 2 by 3. So you could do 2 by 1 and 1 by 1. This doesn't really look like a 2 by 3, but... Maybe you could make some sort of argument as to how many queries you're actually making in this table. And if you're smart about it, it's not that you aggregate the queries with a segment tree, and it's not that you collapse this with some prefix minimum or something. It's just that you don't actually make that many queries with X and Y. But I don't think that this is really an example of that. Could you make some sort of statement about how there's only certain sub cases you care about? Like if this was like 9 by 3, then that's like you really want this to be 3 tall so that you can just split it up into 3 squares, which would mean that like exactly this point is of importance, whereas maybe like this point, a 9 by 4, is like not as valuable. And then you could say like, look at all of those. Maybe. Is there ever any argument to be made that you make all of your X cuts first and then all of your Y cuts? I think that's unwise. I think this is like a direct counterexample to that. That you would neither want to make all of your X cuts before Y cuts or all of your Y cuts before X cuts. I really doubt it's a greedy solution. If for no other reason than this is in the dynamic programming problem set. But also, it just feels too dependent on very specific, like, divisions. Is there any other data structure or algorithm that seems worth using that wouldn't be a segment tree or a sparse table? Not that I can see. Could you make an argument that you will always be drawing square? Here it's a single square, but what if it's you're always drawing squares? So for example, in the 499 by 500 case, what if the first thing you wanted to do was always like 10 by 10? And then there's 10 of these. Because that seems to be the case here. It would look like you always are drawing a 5 by 5 and then a 3 by 3 and then a 1 by 1. In that way, you're always drawing one single square. So here, what would the squares be? And this actually would be logarithmic immediately. You would say, well, and the thought I was going to say here is like you could argue that, or you could say it's incidental that it's always one square. You actually could have said, I want to try drawing the 1 by 1, and then that would land you at the same spot. But you're drawing two 1 by 1s, importantly. So there's never any situation where you aren't drawing squares to limit a rectangle. Although I actually think in the Leetcode problem, okay, both of these abide by that. This does not abide by that at all. This is not possible, though. This is a different question, and I think this actually is substantively a different question. So what would that mean for here? 500 is 5 times 5 times 2 times... Okay, it's 5 times 5 times 5 times 2 times 2. So you'd say, okay, well, there's a bunch of squares that are possible in here. You could have 2 squared, you could have 5 squared, you could have 10 squared. Well, and that's it. So you say, try drawing all of those. But that's predicated on a really specific rule that you will always have a repeated tiling. And I don't really know why that would be the case. That seems like there's no apparent reason for that. But that would give you I guess a few options. This would be something like log n, log of the square root of n, something like that would be the number of options you have per side. And then you'd say this is prime, so the only thing I can do is draw 499 by 499. I don't really want to try that, and then it turns out that that's just completely bogus. I almost want to just try coding out a naive O of n cubed solution. It feels so quick to write in theory that maybe just the act of writing that will give me some ideas. I'm gonna try that. The input line only has two integers, a and b. That's a little damning too, that I have to recalculate the entire thing. That kind of is rough. Rough problem. I guess so. I feel like I'm like not on my game. I feel like it's not that bad. But I'm not able to come up with it. Because it's such a simply phrased problem. Usually the problems that are really rough are like, I don't know. Am I really sure the segment tree thing wouldn't work? Yeah. Because every time you add a node into your segment tree, you'd say, now it's this length, so I have everything else and also this. You'd have to change every other element in your segment tree. Like, necessarily. Okay, well, for I from 1 to n plus 1, dp at I equals 1. That is all the squares. For I from 1 to n plus 1. For j from I plus 1 to n plus 1. So now we're looking at dp at I at j. For k from 1 to I, this is you're slicing in the ith direction. For k from 1 to j, you're slicing in the jth direction. And I think it would really be... No, I think it would be dp from 1 to I. dp at I at j is equal to min dp at I at j. Let's say cur is equal to min cur, or MSF maybe. Hey, Vortism. Welcome. I am struggling on this problem. MSF is min, MSF, and dp at... Let's see, so this is you're cutting into I, so j will be the same. So it'll be dp at k at j plus dp at I minus k at j. So k will go from 1 up to I, and I minus k will go from... It's just CSCS. It's this problem. I minus k will go from I minus 1 down to I minus 1 is 1. Okay. I need to be a little careful though, because I've assumed that j is always greater than I. So what I really want to do is say I1 is equal to min k I minus k, and j1 is equal to min max k I minus k. No, that's not right. I2. This has nothing to do with J. No. What am I talking about here? This is very weird. No, okay. This one happens to be fine. Because I is already smaller than J, and K is smaller than I. So therefore, K and I minus K will all be smaller than J. So I don't need to worry about like dipping into the other half of the rectangle that doesn't have anything. But this part I need to be more careful. So this part I'll say... cur is 0 int I1 is equal to min I and K. Int J1 is equal to max I and K. Cur is equal to, oops, dp at I1 at J1. And then I'm eventually going to reassign these and do that again. So I1 is equal to min, it's going to be the same, basically. But now it's I minus K. MSF is min, MSF in that. And then in the end, dp at I at J is equal to MSF. Okay, and then in the end, print dp at n at m. And then I kind of want to say like, if n is greater than m, swap n and m. Uh-oh. Zero. Shit. Well, I never actually set anything to be anything, do I? I kind of want to set everything to be infinity except for these. One m plus 1 dp at I at J is equal to 1,000,000. Shit. Okay, MSF is showing up as 1, but I'm guessing that's just not dp at n and m. Well, first off, that should definitely be an m and not an n. One cut. It's because I want to say MSF plus 1. 2 cuts. Is this yielding any useful information? No, not really. What did it actually come up with for the arrays? So it said these are all 0. Any hard backtracking questions that are interesting? I guess Sudoku solver is kind of fun. Hard backtracking questions. There was a recent contest question that was pretty interesting. Like Leetcode contest question that was like, Hmm. Last submitted, difficulty, frequency, contest point. That's interesting. I want just the most recent ones. Hmm. Oh my god, I hated this problem. This was not backtracking at all. Did I virtual the latest contest? I think this was the latest contest. I think I did virtual it though. I remember it being somewhat scuffed, but I don't really remember what the most recent contest was about. Oh yeah, I think that was literally that question. Yeah. Yeah, I would say in a way this is backtracking. I didn't use backtracking though. I used like bit masking, but you could use backtracking for this question. I guess I didn't do this. Oh, I remember this question. I'm really struggled with that for some reason. I think I literally have that open on a tab somewhere. Good thing I don't have anything bad open, Jesus. I literally have that open right here. As of like a couple days ago. Oh, well, I'm calling I minus k again. I think I want this to be j minus k. I don't think that changes it. Yeah, that doesn't really change it. dp at I at k. dp at I at j minus k. I think I'm going to get rid of the whole I plus 1 thing. I think that's causing a lot more problems than if I just said from 1 to m plus 1. And then if I equals j, dp at I at j is equal to 1, continue. And then I don't really need any of this nonsense anymore. I think I should just be able to say MSF is min MSF dp at I at k plus dp at I at j minus k. Hmm. Okay, I think I have an insight that could maybe get the time complexity down. Yeah. I think you could show that if you are ever drawing one square, you would want to draw more of the same square as much as you could. I don't even know if that's true. Yeah, I think you could. You could say you always would have wanted to have drawn more of the same square. Like if you drew this one, you would always want to draw this one if these are the only two things left. And the only reason why you wouldn't draw another one here is because you already handled the 5x5. Alright, I gotta call this person back in like 5 minutes. Man, this shit is making my head hurt. TP.ij is MSF +1. What's the problem here? You're saying make a cut. Look at the min of these. I think it's that dp@ij is 0. Right, you don't need to make any cuts in order for it to be there. Okay, so if I said 500, 500, how fast is this? Well, it's not that fast. Zero is also the wrong answer for sure. So why did everything up to exactly 500, 500? Oh, no. 0 is the right answer. Okay. What about 500, 499? I think Betsam said he ran his solution and it was like 15. Was it exactly 15? Yeah. I swear to God, if it's just O of n cubed and he led me on this, like, it's not O of n cubed. Maybe it'll pass. That would be kind of ridiculous. Why did I just waste my time doing that? Oh my God. Was he trolling me? I think he was trolling. What the fuck? Was he for real? Oh my God. Was it even close? No. It was like 0.1 seconds. Okay. I gotta ask ChatGPT. What question is this? $17.44. God damn, what a waste of time. I came up with that in the first 2 minutes. If there's a better solution, there's a better solution. It's good to know, but... God fucking damn. And by ngrid, whose each square contains a letter. Should move from the upper left to the bottom right. Square. What's the lexicographically minimal string you can construct? Wouldn't you always greedily take the smallest thing you can? No, if they were the same. So if you came across a situation where you had A leads to A and A, you have no idea which one you would want to take. Are you fucking joking? There's not even a better solution? God damn it. So I guess, but you could store what is the next... I mean, if n is only 3000, you could literally store the string. You could say dp at ij is the smallest string that you could build. No, because it's an n by n grid. So you need to, this one you actually do need to do it in O of n by n. So you need to immediately be able to tell, go down or go to the left. I mean the right. Well, from there you could say, what's the first point at which these characters are different? So if the characters themselves are different, you immediately have an answer. If the characters themselves are the same, they could also lead to the same character, and then it wouldn't matter. Or they could lead to different characters. So you could say, how far away is the best thing that isn't what you are? And what is it? And then you would compare them. Okay. Okay, I got A, I need DP. And DP is going to be... I'm just going to do that, I think. Okay, DP should just be a bunch of zeros to start, which should be fine. Yeah. So if I is less than n minus 1, if j is less than n minus 1, if I is less than n minus 1, that. So these corner cases are if you're on a side. If I is less than n minus 1, dp at I at j is equal to dp at I plus 1 at j. But now this is your one further away. So distance 1, character 1 is equal to dp at I plus 1 at j. And then distance 2, character 2 is dp at I at j plus 1. If the first character where they're different. I don't think that's good enough though, because they could be, it could be a bunch of A's and then they both transition at 10 A's away into a B, and then they're both the same bunch of B's. Thanks for the raid. I think I've seen FaZe Baki. I don't remember who that is though. Welcome though, I'm just brushing up with some CSES. Virtual of EDU 146. How do I get to it? Oh, okay, thank you. Oh my god, I remember this question. This might be the first Codeforces question I've ever seen. I remember like talking through a solution with a few people, and then like I didn't code it up because I think I programmed it in Python and it didn't work. So I was like, all right, let me do it in C++, and then I like gave up on it. Let me see if I can take another crack at it. I think I was like in like a voice chat with people that were just like wanted to practice it. But yeah, I don't really know why. Got a job in a game studio, developed an online shooter, Your first big task is to help balance weapons. The game has N weapons. The IF gun has an integer fire rate and an integer damage. The IF gun's total firepower is equal to the product. You have to modify the values damage at I of some guns in such a way that the new values damage at I will still be integers, and the firepower of all guns will become balanced. Given the integer k, the guns are said to be balanced if the max minus the min is less than or equal to k. Since gamers that play your game don't like big changes, you need to change the values d sub I for the minimum possible number of guns. What's the minimum number of guns for which you need to change these values to make the guns balanced? The new values must be integers greater than 0. So you have these multiples. You're multiplying by the static array f. You're trying to change the values of d, including the coefficients, such that the total difference is less than or equal to k. Well, I think the first thing you could say is, if you're changing the value of d sub I, you're changing the value of d sub I to be within the appropriate bandwidth, the k length bandwidth. So the moment that you change d sub I, that's kind of the same as getting rid of d sub I. It's not quite the same, because I think if you're multiplying it by f sub I, then you need to make sure that they all wind up generally in the same spot. So like, I feel like if your like damage array was like, let's say k equals 1 or k equals 0, they all have to be exactly the same. And then you said like, okay, for your damage array, you have like 3, 7, and 12. I think you might still be able to do that. You could just say, nope, that's not relevant. I think not quite, but you would basically need, because all these are relatively prime, you would need to have it go to, what's that, 246, I think? Something like that. No, I don't think it's this. Let me think about this. 242? 20 times 12 is 240, so 252. You would have to change them all to this. So I don't think it's good enough to say just get rid of it, because then you'd wind up with an array of length 1, but you would have to get rid of this too. K only goes up to 1500. N only goes up to 3000. F sub I only goes up to 2000. That's very important, actually. And D sub I goes up to 10 to the 9th. So the fact that F sub I only goes up to 2000, that means you can't have some horrible situation where D is like some giant number and then another giant number minus 1. Like, you can't have that. It's only going to be up to 2000. So therefore, I think you could kind of say like, no. Because damage sub I is up to 10 to the 9. What if you said, choose this as the minimum, choose this as the maximum? Is there ever any reason why, if you have like, or I guess D, but whatever, I'll call it A. So you have them ordered. Is there ever any reason why you would randomly change a number in here? I don't think so. So what if you said take every 2 points and then check, can we get every point outside of that to be in here? So what would you do? You would say, look at all of these. Is there any x sub, let's just say like I is less than L, such that you can't multiply it by anything? Yeah. I think it actually matters to not just write like X and Y and stuff, but actually have it be like originally what it is. So this is the minimum to maximum frequencies. Is there some damage that you could assign to all of the frequencies below the area you're trying to get to, such that it's within that, within these bounds? But I don't think you'd want to do that, because I think there's a world where you say the min and the max aren't actually elements, they're just like here, like some other element multiplied to go there, and now you want to use that one. But definitely like examining the modulus seems like probably the way to go. You're always going to center, you're always going to center, let's say you have like all of your elements, and this is sort of like the map of magnitude. And let's say up here is like 1e9, and down here is like 3. These are all of your like damages. I think you could kind of say like, okay, well, this is my K range here. This is where I'm trying to get everything into. You could start here and say, what if this was your range? And what if this was your range? And what if this was your range? Because, well, that's the letter D, but because you know that one of those ranges is going to be the legitimate range. And there's not that many of those ranges. If N only goes up to 3,000 and K only goes up to 1,500, there's like 1 million of those, something like that. 10 million actually, but that's kind of tough because you can't, you would need a way for every element above and below this range to say, is some X sub I up here, or again, frequency sub I, that resulted in a damage times frequency amount that was way too large? Could I say, assign some number to that, multiply some number such that that percent L is less than or equal to R? So it's like if you took away this amount, would it be in this range? And then you would say how many numbers satisfy that. How many numbers satisfy that frequency? I think the question kind of becomes, I don't think you can just like immediately calculate that on the fly, but maybe you could aggregate it. So you'd say like every single thing that's not this point, just like for the very first thing, like take O of N to see if you can stick them all in this range K. And then when you go up here, like add this one in and like adjust all the other ones appropriately in O of N. but I don't think that's would work. Because you could jump just a completely random amount to another interval. When you jump here, this could be like a 10 million jump. There's no way to be able to like use previous info for that. Maybe you completely ignore damage to start, and you say, no. Maybe you go the other way and you say, I will additionally constrain my k interval so that I don't just center it around every point to see if there's an interval that works with a point. I could center it around that, and I could also center it around for every other point. The moment a point can't reach there, like if the furthest it can reach is there and then it could reach there and this k interval like doesn't work, then you have to just skip this. So then the question becomes, yeah, is there any interval at all when you choose a certain interval k? Is there any element at all that can't be placed in k? If I can answer that question, then I have my answer. It's like basically a sliding window. Well, you could every single time you start a new interval, if you started here, you could say, for every single point that's not in this interval, yeah, I think this would straight up be it. You would say, for every single point that's not in this interval, could you stick it in this interval? So you'd say, like, for all f is f sub I percent L less than or equal to R in this interval of size k. If not, I don't even think you say is it, you just say find that. And then you sliding window through. From p sub I minus k to p sub I up to p sub I to p sub I plus k. And you keep track of all p sub j in the window, all f sub I times x in the window. Okay. And then you would update these as L and R reach thresholds. So you'd say, just wherever this goes, put this at the lowest possible multiple that is above L. And then as you increment this window, you would eventually reach it with R, and you would say, okay, now that's there. Let's say like there's no point here. Then this would be the first window where you could say, okay, everything's actually in this range. And how many elements started out in this range? Only one. So then you would set MSF. And then if you kept going, you would reach a range where... It's not a great example. Maybe you have another point here where you say there's a point, like its multiple is there. And then once you reach there, you'd say, oh, now this is outside of bounds. So now no matter how far up I go, it doesn't matter. This will always be an invalid range because there's something that's not able to be made to be within this range. Or you might not necessarily say that. You could also say, once you reach this, bump it up to the next value, and then it'll go there. And then maybe there's a little bit of time where there's an invalid interval, and then you would reach it again, and then you would say, okay, like there's now 3 points once again that's in this range. Or that are able to be made in this range. I think you'd have to be really careful to not have this be O of n squared log n squared. Because if this, for example, was like f sub 0 was 2, then you could have something where like you're constantly just bumping it up by 2 each time. And you're like, oh, it's invalid. Okay, it's valid. Okay, it's invalid. And that would be like O of n every time, like just for this 2. And then you could have like f sub 1 is equal to 3 and f sub 2 is equal to 4. And you would bump these up. And you would have to spend log n to do that. But then also, I feel like the way to bump them up, you would kind of need a priority queue. Maybe you wouldn't need a priority queue. I think you could just use a bit set that's like, or a 2D array that's like, is there anything at this spot that needs to be bumped up? That's kind of convoluted though. If you had an array, I think you could use an array. That would be fine. So then that would get this down to O of n squared log n. Okay. Well, that's what I would do for this one, I guess. This was 2 years ago. Wow. Alright, I gotta head out. I feel like 3 people's barely enough. Nah. Alright. I'll look at B really quickly. Long legs. I liked that movie. The robot is placed in cell 0, 0 on an infinite grid. The robot has adjustable length legs. Initially, its legs have length 1. Let the robot currently be in cell XY and have legs of length M. In one move, it can perform the following 3 actions. So go up by M in either direction or increase the length of the legs by 1. What's the smallest number of moves the robot has to make to reach a cell A, comma B? Oh, I see. It's saying, like, at any step in the process, it could be at cell XY. Well, I don't think there's any world where you ever go above the square root of n, like length of legs. Because, like, at the point where you're going above, like, 100,000, you would rather have just gotten up to that length and then started walking. Yeah. So I guess what you could do is move up to the square root of n, move the square root of n, rounded down. You would have a little bit of extra, and you would add 1, because you'd say, at some point in the process, I was exactly at the right spot. Okay, that's in 1 dimension, though. In 2 dimensions, I don't think it's that different. I think you would just go to the square root of the larger of the 2. So for 8, comma 4, what would you do? The square root of 8 is 2, basically. So you'd say, increment the length of the legs to 2. Move to the 4 spot. And then it would take 4 to move to the 8 spot. So I guess maybe well, I said the square root of 2 rounding up. So if you did that, what happens? You would say, or maybe I didn't, but that's what I was thinking. You could round up because there will always be some number below the square root of 2 where you could have taken 1 step to mitigate any inaccuracies in where you're stepping. So you could say grow the length of the legs to 3, step 3 to get to the 0, 3, step 1 to get to 0, 4, because basically, like, if your legs are above a certain length, you could have walked that length at a previous time. So that length is available to you to walk. And then step up 1, up 2, now you're at 6, 4, and then so 1, 2, 3, 4, 5. Wait, no. Grow the length of your legs to 2. Grow it to 3. Step to the 3, step to the 4. Do you really have to grow the length of your legs to be 4? Step to the 4. Step to 4, 4. Step to 8, 4. Yeah. That's because it costed you one less to have to step to the 4. And one less for the 8, for that matter. So if you ever get to a spot where your leg length is perfectly divisible by the distance left, then you don't have to pay that extra 1. And if you ever get to a point where your leg length is the GCD between A and B, then there's 2 extra that you don't have to pay. Well, I guess there's some monotonicity. If your legs are too short and you try moving at that length, I don't know if that's true. But maybe. If your legs are too short and you try moving at that length, you would have been better off lengthening them. And if your legs are too long, you would have been better off shortening them. I mean, that sounds tautological, but I don't think there's any world where your legs are too long and then you go up by 1 and now it's like better. But maybe here, if you said, I'm going to try to aim for a leg length of 3, you'd say 1, 2, 3, 4, 5, 6, 7, 8. It takes you 8 to get to the end. For a leg length of 2, it takes you 1, 2, 3, 4, 5, 6, 7, 8. I think you could just like actually point blank be like, for every single leg length, how long does that take? You could say if I increased to a leg length of 1, how long does that take? If I increased to a leg length of 2, you could actually just brute force that. With the understanding that if you have a leg length, you could have walked in a given direction with a shorter leg length before. So that's basically the same as like having access to that amount to walk. But then how high up do you go? Because apparently sometimes you don't really want to go beyond. Or sometimes you do want to go beyond the square root of the larger number. But I just don't think that's true in the long run. I think if you said the square root of the larger number plus 1,000, any corner case, it wouldn't matter. I feel like this won't be that hard to code up. It's going to be the minimum of y and square root of y plus 1000. Damn. Okay, for I in range from 1 to lim, the worst possible case is it takes you x plus y. You just immediately start going. So for I from 1 to lim, I guess I can say 2 to lim, current equals x over lim plus x percent lim doesn't equal 0. Curve plus equals y over lim plus y percent lim doesn't equal 0. I think that's right. Oh no, this is no, that's right, that's right. Why did I say percent lim? I think I want percent I. And also over lim doesn't make any sense over I. I'm losing my brain here. 3 still doesn't sound right. Because I forgot I itself. Six. That seems right. Two, 5, 6. Well, I kind of want to check like if we have a really big number. So this should take somewhere around the square root of them. Times 2. Times 3. Yeah, that looks about like the square root of n times 3. Third numbers differ. Found 3, expected 4. $41, so there's 20, probably something like 19 test cases. Third numbers differ. Expected 3, found 4. So for 2 and 2, I guess I might as well be safe and say y plus 1. Okay. Close one. Can you tell why plus X% I doesn't equal 0? I guess my thought process is like, if you are... First numbers differ. Not a good sign. Well, that... maybe not. No, that's not a very good sign. Because... the idea is... Okay, 68134. Am I too large or too small? 66903. I'm too large. That's a bad sign. The idea is that if you're walking in a given direction, so if like this is x comma y, right there, if you have some increment by which you're walking, and you, let's say like in this direction you exactly get to the right spot, but then in this direction you overshoot. The idea is like X% I won't be 0. It won't be perfectly divisible by I. So therefore, in growing to this distance, there should have been some small distance where you said, oh yeah, and also randomly I'll step this way 3 units. And then the whole thing shifts over 3 and it works out perfectly. But that only costed you exactly 1 no matter what, because there always will have been some previous smaller distance where you wanted to move exactly that. That's my thought process behind that. Plus X% I doesn't equal 0. Although I could very much see a problem with it being the PEMDAS has issues, because it seems like I don't fully understand the order of operations in C++. No, it wasn't that. I think... What happens if I just say the square root times plus 100,000? What happens then? Well, it gives the right answer. I'm still, it seems like not a great strategy. This is like worse than brute force to go. Not only am I going to brute force like up to the square root, I'm going to brute force past that to some random other point. That seems like not a great strategy, but whatever, I guess. Let me grab these. This is probably something like 10 or 20 maybe. Let's see what this comes up with. Oh, come on. Okay. 66903, 67546, 45402, 57358, 71773. All right, that looks good enough for me. That's so funny. If my janky brute force solution works, I'm gonna be happy. That's so stupid. I wonder what my previous submission was for this. Try not changing each gun. Compare to each other gun. Make sure each other gun can be changed to match. Okay. That seems almost exactly like what I was thinking about here. Only now it's in C++. I'm out. I'm outie. Has any new Leetcoder started to stream? No. All right. Thanks for joining in. And thanks for sending that contest too. And thank you, Jackson Wang, for following as well. See you guys.